In this session, I'll be explaining external computational fluid dynamics and give live demonstration on external incompressible CFD analysis. Now, I'll give a live demonstration on external incompressible CFD analysis of landing gear using SimScale software. SimScale is a cloud software in which you can run your simulations without need of a powerful computer. You can run your simulations using laptops, tablets, or Android phone. Let's get started with our analysis. To open the SimScale software, you just need to open your browser or Microsoft Edge and enter simscale.com. Go to the dashboard. Here you need to create new project. So our project title is landing gear. So I'll enter it here. And project description, you can enter of your own choice. So here I'll be entering external incompressible CFD analysis. Category, select aerospace and click on create project. As you click on the create project, you'll enter the interface of SimScale. Here on the left of your screen, you have the navigation tree. On the right, you have scene tree. So you need to import geometry for your analysis process. To do that, you need to click on this plus icon in the geometries. So you need to import your geometry from the computer. So click on import from computer. So where you have saved your geometry, you just need to import it. So after selecting, click on import. Yeah, it's imported. This is your landing gear geometry for analysis. To do analysis, we need a domain. To create domain, we'll be using enclosure function. For that, you should right click on the landing gear, add geometry option. Here is the enclosure function. Click on enclosure function to generate domain or virtual wind tunnel for the analysis. While creating domain for our geometry, we must consider some points like domain which we are creating must be far away from the boundaries of the geometry. The domain dimensions must be considered such that the flow near the geometry is not affected by the conditions at the boundaries. The standard dimensions of the domain considered for analysis are the inlet wall distance from the geometry is 10 times the length of the geometry and the outlet wall distance is 15 times the length of the geometry or 20 times the length of the geometry, and the other sides of the domain are 10 times the length of the geometry. Now for my geometry, I'll create a domain. domain is created for the geometry. Click on cancel. Click on the faces of your domain. Right click, hide section, zoom. Click on the box selection. Select the landing gear geometry. In the scene tree, click on the plus icon and give name for the geometry. So I'll give landing gear, CAD mode. So you can name it of your choice. Click on create new set. Then right click, click on show all. So this is your geometry with domain. So this completes our first step in analysis, that is pre-processing step. The next step is the solver execution step. For that, click on the plus icon in the simulation. So simulation will be doing incompressible. Click on incompressible. Then click on create simulation. Next, we'll assign the material. Click on material. So our material will be air. Click on apply. Keep the default values of kinematic viscosity and density of the air, and the assigned volume will be the flow region. Save it. Next, for initial conditions, keep the same default values. Next, we'll assign boundary conditions. Click on the plus icon, velocity inlet. I'll give velocity as 60 meters per second. To select the face, click on translucent surfaces with wireframe. Select your inlet face and save. Next is pressure outlet. Here enter the pressure. Select the outlet face. So for my geometry, this is the inlet and the outlet will be the opposite one, opposite face. Save. Next, click on the plus icon. Go for wall boundary conditions. Select moving wall. So moving wall is that phase along which the velocity magnitude is specified. That is defined as moving wall. Enter the velocity 60 meters per second. Here for this problem, the air is flowing along x-axis. This is the inlet. This is the outlet. So the air is flowing along x-axis and the velocity magnitude is specified along x-axis. So I'll select this phase. I'll define this phase as the moving wall. Here you can rename it as moving wall. Save it. Next, again assign the boundary conditions, wall boundary conditions. Now for the slip walls. The free walls of the domain are defined as the slip walls and which will slow down the air. Assign the faces. Rename it slip walls. Save it. Here we are done with assigning the boundary conditions. Next, in advanced concepts, click on numerics. So I'll keep the default values, save it. Simulation control, I'll keep the same default values. Next, we'll assign the result controls. Click on result controls, then plus icon in the forces and movements. Then forces and movements. In forces and movements, you need to assign the CG value, center of rotation. Here you can see the CG of the landing gear. Select the phase as the landing gear from the scene tree. Save it.